Yeah, apologies first for a slight technical glitches here at the start. I hope this will not be recurrent. Welcome to the first unofficial hallway meeting for, or the first unofficial meeting for, well, the first meeting for ASDF really, which is an unofficial hallway meeting. And the intent was try to get going as soon as possible. I was hoping that, so let's get going. First of all, this is a, even if it's an unofficial one, it's still an IETF meeting, so there's the note well that you should note. Basically, will be recorded. Remember to be nice and professional, and then also, of course, remember the IPR guidelines. So this meeting falls under IPR policy of IETF. There's a link to the repo where this material is found, and also to the notes on CodeMD. Yep. And here is the long note well. I guess you don't need to read that because you probably have before, but here is if you want to see it. Anyway, here is the agenda for today. We'll do a quick introduction. This one right now. Say a few words on administrative bits and do some agenda bashing. So, do we have somebody who could take notes?
I'm taking notes actually.
Okay.
So, do we want to spend so much, given that all of the names are quite familiar? Do we want to spend as much time on the tutorial as planned?
Well, not necessarily. Let me see here how we are on the. We have some folks who maybe not so familiar with this, so I would see yes, yeah. This is a rough timeline, and it's also about if we get questions or discussion points. So that this is a rough, I would say, a rough outline. Of course, the faster we can get through the tutorial and the background stuff, the better it is. So consider these guidelines, not rules.
Briefly, I switched computers. So would someone put a note to the GitHub repo in the chat, please? Or sorry, a link to the GitHub repo in the chat.
Yeah.
Thank you.
Repo or the CodeMD?
Oh, it's just okay. It's the same link. Sorry, I thought it was different somehow.
Well, I just put in the GitHub repo as well.
Yeah.
Okay. So, well, of course, since most of you here are familiar, but still, we wanted at least one intro slide. What is ASDF? And super briefly, this is the IETF working group that is being formed to specify the semantic definition format, and it follows up on a BOF with the same name that took place at IETF 108. And then what is SDF? We will talk a lot more about that, or Karsten will talk a lot more about that in a moment. Briefly, it was created by the One Data Model group as the way to describe IoT device information models in a highly portable fashion to improve semantic interoperability across different IoT ecosystems. And the first spec is well, the outcome of the One Data Model work, and which is now the input to this work, is this SDF, the first SDF spec, SDF 1.0, and there's a link there. You can find it on IETF, and the intent with this working group, of course, is to improve on that work and continue building on it. So the question is, of course, where are we now? I shouldn't say limbo, but we have passed the ISG reviews, as we understand it. There are no final objections. We've sent the final charter to Barry, and so really we should be up and running any day now. So I guess it's just basically a couple of days until we are formally a working group. And that's also one reason why we had this unofficial meeting here today, that we can't really call for a meeting until we are really working group. The chairs, Michael Richardson and myself, Niklas Vidal. And here are the rough plans from meeting perspective. We had this hallway meeting today, just to get going and do a brief tutorial. We have a virtual interim, hopefully in about 2 weeks' time, so we can call for adoption on the first draft. Then, as we get closer to IETF 109, we plan to do some in the hackathon week before IETF 109, do some preparation work for SDF 11. I have a long list of ideas there. And then for the actual IETF 109, there is a 2-hour meeting slot requested. So we will meet then. Yes. And if you have no idea what one data model is, Karsten will talk more about this. This is in a nutshell picture that I used. Basically, the problem we're trying to address is that there are several standardized data models, but there's a lack of interoperability across these ecosystems, which making integration a hassle. To address that, we tried 2 solutions. One was to select one ecosystem and everybody joins that, and that of course did not work out. So instead, we decided to facilitate translation between the ecosystems via a neutral format. And that neutral format is of course SDF. So SDF is one output of this one data model work, and that is now completely handed over to IETF to further develop. Then we have work on tool chains that translate between SDF and the various ecosystems. And of course, we're also, while we're at it, we'll be developing a set of IoT device models or IoT data models that can be widely reused. And if you want to know more about onedatamodel.org, there is the link there at the bottom, onedm.org, nicely. Good. That was my intro slide. So are there any, before we continue, are there any additional things people would like to add to the agenda before we continue? I can go back to the agenda. Any additional agenda points? No, if not, then I'll let Karsten take over. And Karsten, can you drive the slides from your side?
Yes, I try to. Someone fixed the bug in Chrome that made it take 2 minutes to do this. So I now only need 20 seconds for that. So can you see my slides?
Yes.
Okay, so I want to give a brief overview over SDF, the semantic definition format. Some of you will know some of these slides because I gave a similar overview 6 months ago about what then was SDF, but these are slightly updated slides, so there are some new there is some new discussion in there. So the image that Niklas showed should have made clear what we are trying to do here. So we have several ecosystem-specific SDOs, standard development organizations in IoT these days, and they usually do their own data models. They don't often actually call them data models, but that is changing. Anyway, they standardize the data that their IoT devices are exchanging, and they have their own way to document them as well. And given that applications may need to work with things that are standardized in several of these ecosystems, we are in a position where we actually need to translate model information between the ecosystems. Well, one-to-one translators are hard to do because really there are hundreds of these data models. So at some point in 2019, people decided to start liaison work between the different SDOs. The One Data Model Group is an informal liaison group, and this really is about a way to harmonize data models, to have a way to translate between them. And the obvious way to do this is defining a common format, and that is what SDF is trying to be. So SDF until summer has been defined by this informal liaison group, so that there are several organizations there, like OCF and OMA and so on, that have significantly contributed to that. And essentially what SDF does is it defines classes of things, and these things have interactions. These interactions are defined by affordances. This is a term stolen from interface design, where you have a device with a button and a knob and so on. These are affordances, and we use them for the different kinds of interaction that a device can have, like reading the temperature and setting a set point and things like that. So these affordances are not completely random. We found that we have three major interaction patterns: property, action, and event. This will probably refined at some point in time, but right now it's a good way to start. And what SDF essentially does is naming these patterns and providing models about the data that these interaction patterns exchange. So when you read a temperature, you probably get something that looks like a number, and then you need to know what unit that number is in, and maybe other information as well, like when was the sensor last calibrated, and so on. So this is the kind of data we want to define in the simple definition form. So it's not a general data modeling tool, it's a tool for modeling the data that are interchanged as part of performing an interaction pattern. So the structure of SDF specification that One Data Model came up with was putting these into JSON documents. That's a kind of a logical decision when you think about the fact that this mainly goes into translators. So everything that's good for a translator to work from and to work into is useful, and JSON is kind of the standard and generic data model that we use for things these days. And we also use RFC 6901 JSON pointers to point into these JSON documents, because we don't just need to talk about whole documents. We want to reuse data types exposed by specification and so on. In the long run, we want to have something like a basic call set of data types that specifications can reference. SDF 1.0 contains everything that's needed for that, but we haven't actually started exercising that. So I would say that the mechanism that is in SDF 1.0 is untested, and we really have to start making use of that to be able to say, okay, that's really it. We can live with that, and we probably will come up with a few tweaks for SDF 1.1. So SDF 1.1 is my name for the next version of SDF, but of course you might decide that we don't want to do it now, that we will do it in SDF 1.2 or whatever. So that's the purpose of the next segment, to talk about solutions and prioritizing. So let's talk about those interaction patterns. And I said there are properties, actions, and events. And these actually come in some variations, so that there are readable, read-only properties, there are writable properties. And if you are used to thinking of IoT devices in terms of REST, then this slide is useful for you. Otherwise, it's maybe not that useful. So a property has something like a get operation, where the client, which is not an 1DM term, not an SDF term, but it's a REST term, where the client can take the initiative and read some data. And a property can sometimes be put, for instance, if it's a set point or something that's not just a measurement. There are actions. So for instance, there might be an action to switch to a different scene in the lighting system. So actions are modeled as post interactions, and they have input data and they also have output data. And finally, there are events which don't directly exist in REST. There are various hacks to add events to REST, and there the initiative is on this thing side. Something has happened and the thing wants to let you know. And this is essentially providing some output data. So we see we have mostly data specifications, and we have a little bit of interaction specification as well. Yeah, how you exactly do this may be a little bit different in different applications. So in the REST application, an action might have something created that will provide event-like things while this action is going on, and so on. We haven't gone into that level of detail, so we haven't said how actions and events might relate, and so on. And actually, we have properties that are observable, which means that occasionally the thing actually will have the initiative and provide data to the client in the same way as if the client had done property get. So finally, we have events, and these are probably the least well-defined, but at least we have a way to say what the output data will be. So all these are talking about data. And talking about data, first of all, we need to talk about their shape. So is it a single number, or is it maybe an array of numbers, or is it a string? And these data definitions can be made in an affordance definition, or they can be made separately. In particular, if you want to use a common data type, you would do that. And for the data definitions, we currently use a subset of JSON schema.org terms, augmented by SDF-specific terms such as content format, nullable, scale, whatever. And what we haven't really done, we have talked about, and probably a few ecosystems have prototypes for that, mapping information that provides a way to bind these data definitions into the ecosystem specific formats and encoding. So it's not the point of the data definitions to tell you that there are 5 bits and the third bit from left does that. The data definition would stop at the fact that there are 5 Boolean values. So this is an example of the more general observation that really SDF is about information models. So we don't want to tie a harmonized data model down to one specific representation. So whether you use an integer that goes from 0 to 65,000 and 32,000 means 0, or you use a floating point value, this is really not important for the information model level. but it's important for the bindings. So that's something we will have to work on. And we also will have to work on making the semantics more well-defined. So we might want to do something like adding RDF-style links to our information models, so we actually know what the names mean. So if you have a data model that has 3 fields called R, G, and B, that doesn't mean that you understand what these 3 fields actually mean. And it would be good to actually tie them, for instance, to primary colors in some color space definition and so on. So we have a gap here between the description capabilities of JSON schema.org, which is the data modeling language, and the information model that we are really trying to define. And this currently comes up in the enum concept. So JSON schema.org has enum data type, which is essentially just a set of values, which can be, for instance, strings and integers. And each of these denotes some specific concept. So to the lower right on the slide, you see the enum that the OCF battery material model uses to describe the chemistry and the construction of the battery. And this is just a set of strings. These are the strings you can use. And if you have a potato battery on your IoT device, which you might have because it might be a toy, then you only have lemon potato there, even though you do not employ lemons. So yeah, it's somewhat difficult to define these enums, and they kind of get arbitrary after a while. There might be spelling errors. So the Pulvermacher's chain, the guy is actually called Pulvermacher, and there should be an apostrophe here to say it's Pulvermacher's chain. And also it's 150 years obsolete, so nobody uses these anymore at this point in time. So it's not even clear that they should be in there. So these enums are difficult, and it would probably be nice to be able to point to something that has done the work of enumerating the cases. So if we were talking about cheese firmness, for instance, cheese firmness actually has a definition somewhere, I forget where, and we would not get the idea of defining our own kind of cheese firmness enum, but we would like to point to that. But that may not take the form of an enum of strings. And on the other side, on the data model side, so maybe somebody uses the number 34 for lead-acid gel batteries, and there's nothing wrong with that. That would be the job of the binding to say that what's lead-acid gel in the model is actually 34 in the representation. So in SDF 1.0, we only have the possibilities that JSON schema.org gives us here, and that leads to some pretty questionable definitions. So is an alarm always one of the 5 categories: general, fire, flood, weather, or security? And we also need to think about extensibility. How do we provide extensibility? Do we use something like IANA for registering code points? Do we use URI so everybody can define an extension? Do we do both? And that's clearly something that SDF 1.1 needs to address, because we are getting more and more of these enums and need a good way to handle them in an evolvable way. So from these basic components, property, action, and event, and the data definitions that are referenced from these, we can build objects and things, and that's our composition mechanism at the moment, and that's probably also something that needs more testing at this point in time. We have a few SDF things, but mostly we have been defining SDF objects. So if you have an outlet with, if you have a extension strip with 4 outlets and 1 fuse and 1 metal oxide varistor in there. How do you build that composition, and how do you handle the repetition that is in that composition with the 4 outlets that are otherwise equal? So we haven't really done that a lot. And when we did SDF 1.0, we deliberately decided not to include the JSON schema object type, which really leaves a big hole in SDF 1.0 because we cannot really describe composition at the data model level at all. But the question we first have to answer is, do we really want to handle it at the data model level, or is there something in SDF that describes how this composition is done? So simply providing several properties also is a form of composition, but it's not always the right way to handle it. So some of the composition will be above the property level, some will be below the property level, and we have to figure that one out. Yeah, we specify SDF specifications, and since the specifications are JSON documents, we also can specify them in a data definition language, and in this case we actually want to use the full power of a data definition language. So the current draft has a CDDL based specification, and that is also translated into 2 JSON schema org format definitions, one that is very open, so the framework one, so all extension points are open, but that also means that a typo that you make might be mistaken for an extension. And we have the validation schema that is limited to what is defined now. So CDDL has recently grown a feature called feature, and can handle that in one specification, and in the JSON schema org translation we handle that with 2 different specifications. And of course that's not all we need, so there's also some English prose in a markdown document that is the internet draft. And there's also tooling that we use that might provide some additional specifics. So last slide, where are we? SDF 1.0 has been stable since June. We have a couple hundred data models in various repositories in the One Data Model organization, Playground, Exploratory Unit Tests, and we have tools. We have been focusing a bit on getting the working group established in the last few months, but also on defining One Data Model processes that really aren't the domain of the ASDF working group. That is focusing on the SDF specification. But of course, OneDM itself needs to have ways of doing things, in particular doing the harmonization. So given that the ASDF working group is almost existing now, we can put the focus back on evolving SDF. And so we should define objectives for SDF 1.1, look at solutions, and start deciding. And all that shouldn't be done on a piece of paper. It should really be tested. And one way to test this will be next month, before IETF 109, the hackathon that comes with every recent IETF. And I have put in a hackathon project called ASDF Getting Ready for SDF 1.1. So that was my quick overview. And before we go into full discussion, are there maybe questions, clarifying questions that we want to discuss? So I'm not.
Anybody else?
Anything.
Unmute yourself and go ahead. If there's any questions?
Everything is super clear.
So, Karsten, maybe you could say just 2 words and tell us why this is not Yang.
Yes. So I actually had a slide at the bottom that I would probably like to show at this point. So Yang is supposed to be the data model that people generate code from. So it's very, very implementation oriented. It's not designed to bring data models from different organizations together in some form. So it's a very specific data model. A lot of representation questions are simply nailed down in a Yang model. You don't get to write an information model in Yang. It's always a data model. So it's not really set up to do this harmonization kind of work. This doesn't mean it could not be done with Yang, but I think it just wouldn't work because it would be too much effort.
Thanks.
So from the point of view of SDF, Yang is maybe just another ecosystem that we want to translate into and from. And there has been some discussion already on doing this. Of course, we would need people from the Yang ecosystem to actually help us doing that.
Maybe to add to that, I think it's largely about where these things come from, right? Where, I mean, so SDF comes from working hard to translate between data models, and that puts a certain set of requirements on the tools you have. And Yang did not work out there. So. Yes, okay. Thank you very much, Karsten. Hopefully everybody is now totally clear on what SDF is today. And with that, the second main topic of today was to discuss about this SDF 1.1, what that would be, what that will contain. And to do that, Michael Koster put together some slides, and where he describes a bit of the outstanding issues, elaborates a bit more on what Karsten mentioned as problems going forward that we would try to address.
Okay. Should I share my
screen? Can you share?
Okay, yes, I can. Let me see. Give me a second. There it is. There we go. So this basically is a result of trying to take all of the existing data models that are in various ecosystem and SDO formats and make SDF models for them. And so there were some things that were really awkward and difficult, and also other things that sort of showed up. So this is really work that was in progress when we did a feature freeze of SDF. And this is stuff that might have made it into 1.0 if we had spent another few months, but also makes a lot of sense to consider in the broader context now, since it was mainly the gaps that were exposed by trying to include more diversity in the models. And so very specifically, as Karsten said, we've been focusing more on the object definitions, which are the reusable, the most reusable elements. You're supposed to be able to take an object like on-off power control and use it in any kind of device because it's very, very generic, and it's going up the stack to thing definitions and composing them, we haven't done a lot of work yet. But this is sort of about defining or expressing what's already been defined in other ecosystems like Zigbee and Bluetooth Low Energy and OMA and what have you in OCF. So these are things that showed up when trying to make good representations of existing models. And the point of view here is that someone from that existing ecosystem, like a Zigbee, someone who knows Zigbee, should be able to look at an SDF model and say, oh yeah, I recognize all of that. And that's even easier for me to work with because it's JSON and it's more abstract, and it separates the binding and the detail representation from the semantics and all of these things but we basically still have to have the basic patterns. And so this is sort of where there are some specific patterns that weren't easy to represent and need a few more constraints and features in the language. So it's enumerations, as Karsten mentioned. There's something about reusing SDF property that with OMA lightweight MTM, it's fairly simple, but it needs an extension. There's also composing SDF data, SDF property, which Karsten mentioned as well. And then there's a specific issue with the way that values are used that seems to bubble up to the information model and isn't just an encoding issue, but to the extent that we should figure out how to abstract things in SDF so that they are just encoding issues whenever possible. So these are the four things that kind of need to be addressed in order to create good models of things that can represent all the different contributors to 1DM, as well as they're useful for other kinds of organizations like digital twins and things like that that we've been looking at. So. Any questions here? If no questions, I'll just jump right into the four and give you an outline of each. There's a GitHub issue for each of these for the detailed discussion, so I'm not sure how deep we need to go today. But basically, for enumerations, what we'd like to provide is, I think, as Karsten mentioned, in 1DM, a semantic anchor for each piece of the enum. And so the JSON schema.org gives you an array and you have an array index for each selection, but it doesn't really give you a semantic anchor. And whether a JSON pointer is really what we want or something that's more an IANA registered thing or how that works, we need to talk about. But I think that at the very least, SDF needs a feature to make this abstract and extensible, right? To not nail things down. And so it could be a simple array enum that had pointers to some IANA registration, URIs, but even that would not be very reusable within SDF because it's kind of too opaque. So what we're looking at is something that is a little less opaque. But let's figure out the balance here. So we want, as Karsten said, we don't want to nail it down whether it's a string or an integer or whatever. We want that to be kind of a mapping to a runtime or and really for interoperability on networks, we end up choosing a representation, but we don't really want to nail that down at the most abstract layer of the model. We want to be able to layer that on. We want to be able to have this, as mapping files, this loose coupling, and basically, we want to, as I mentioned earlier, we want to preserve the JSON-ness of the system and not have it be too opaque. An array index is a little difficult. And I guess this slide, next slide shows a little more of what the point is. So the proposal is a new class in SDF called SDF enum that has its own thing and allows you to type a data as an SDF enum, where each selection is its own SDF node, if you will, or thing you can point out with a JSON pointer. And it has a string and then other, what we call qualities in SDF. I've only shown a description here, but you could add, default and constant, and you could sort of cast things A lot of the SDF constructs could be used in what we call mapping files as well. So if you had JSON schema constraints you wanted to add, you could do that in a mapping file and not in the basic model. So what I'm showing here is just the minimum of the basic model, which would be each selection of the enum has a semantic anchor, which is the I've shown with the JSON pointer here, SDF data on off state enum off. That is fully descriptive, and if you know what SDF data and enum classes are, you can pretty much decompose this path into a position in the model. And so as you have a more complex model, you can do things like dereference the links. And we want to be able to have the enum elements part of that processing of being able to be pointed at with the JSON pointer and have each one be its own thing. And then if we decide there's an IANA registration or something like that, that can be done explicitly as maybe one option, maybe the preferred option, but not to lock it down as the only way to do things in SDF. So that's kind of the idea with enums and what where I think is going with that. And basically what happens is, and the reason it kind of needs to be this way, the use case justification for it is that different ecosystems represent the actual on-off values that go over the wire as Booleans or ones and zeros or text strings. And so we couldn't really even harmonize models if we had to pick one of these representations up front. What we want to do is be able to have different models represented with the same SDF and then have bindings. And then eventually we're going to have to choose a single binding for some smaller scope network interoperability. Like if I want to certify devices in Zigbee, I have to kind of choose a wire format, but that's not really what we're doing with SDF. We're a level above that. So that's why this is needed. All right, any questions, comments on enums? Let me know if I'm going too slow or you can speed up a little bit. I'm kind of conscious of the time here. So this is an easy one, really. It's reusable SDF properties. So in Ipsos Smart Objects, they have these reusable properties. So I can say Ipsos Smart Object sensors all have a current value, and sometimes, you know, it's a different type or whatever data type. It might be the same type, but basically it's common of all a bunch of different what they call object definitions also. And so we wanted to be able to have SDF property to be something that you could just define as a reusable thing for everybody, everyone that participates in SDF or everyone that uses one data model or whatever. We wanted to be able to have the property to be a standalone definition and also to be reusable within other property definitions. And I think we probably already provide a way of reusing it in other property definitions that we don't disallow in the schema, but we wanted to add it to the spec. And this is mostly to handle what Ipsos Smart Objects is doing, but it's also the design pattern or useful design pattern. So that's another one. Fairly simple and self-contained, but not allowed right now, and we need to add it.
So right now we can have an SDF ref in an SDF property.
Yes.
What else do we need?
I think, well, we need SDF property to be able to be, well, actually, that may not be an SDF. This may be more of a one data model constraint with the way we organize our database. There may not be any issue, but an SDF file should be able to consist of, a valid SDF file should be able to consist of only SDF property definition and shouldn't be required to contain an object. And I'm not sure what the schema looks like. So it kind of needs to be checked. And also we need to build the model because we don't really have an example of this. So as I said, this is probably very simple. It may not even need a schema change, but I think maybe at the top level, we might need to allow a valid SDF instance to contain only property definitions. And I think now we're only allowing object, thing, and data, but I'm not sure about that.
Yeah, I think we need to actually generate examples that
Yep.
use this,
Yep.
and make sure that our various tools can actually act on specifications that have this. So I think there's work to be done, but it may not be specification work, or it may only be specification work after we learn about what doesn't work so well with what we have defined now.
That's good. Yes, exactly. Okay. Okay, so moving on. Composite property is the thing that's probably the most interesting, because when we look at the way a lot of, well, there are a few different use cases. One obvious one is the multiple sensors that are offered by Bluetooth Low Energy and other specifications, where data from multiple sensing elements can be combined and returned together in a complex format. So generally, I think, as Karsten mentioned earlier, what we'd like to do here is stick to the semantics and not be too constraining on formats and representations. And that even includes schemas where it might be a JSON schema or an XML schema where tag names are part of the schema that aren't really part of the data model. The data model semantics anyway, where tag names are something that you sort of put on over the wire and have the endpoints be able to recognize. But to build them into the data model is kind of getting into what we were calling mapping and protocol binding. So what we'd like to do is be able to compose properties, I think, without more freely, without constraining the structure of what the composite property looks like when it goes over the wire or over the air. So it's kind of like what we already do for actions and events, where we say an action might have multiple input properties, where you could send it. The most obvious common example is probably changing the brightness of a light bulb, where you want it to smoothly change brightness from the dimmer to the brighter over a period of 1 or 2 seconds. And so you send a time parameter along with the target brightness or the incremental brightness, or however that works. So you're sending multiple data items. Well, what happens is a lot of the data models and IoT devices and interactions out there are sort of complex. Probably the easiest one to think of is RGB, as Karsten mentioned earlier. The RGB data is one that we use, but it goes both ways. RGB is sort of like where you'd like to treat it as a property, but it has internal elements. And there's also times where you'd like to roll up a number of properties into a larger sort of thing and treat it as like a configuration data element or something like that. And that's very common in a lot of IoT data models, especially ones that are more service-oriented and less just about describing simple devices. So in both of those cases, though, the requirement is similar in that you want a sort of it's sort of starting to look like the enum, only it's for multiple elements, where you want a semantic anchor for each element and be able to have a description and be able to have it to be its own extension point for adding more qualities and constraints and schemas and things like that in the mapping. So you want to be able to point at it with a JSON pointer for the mapping. And also in describing the composite properties, sometimes the optionality constructs are needed, like any of. So you might have a couple of different optional collections is another way to think about collections of data elements that you can either look one way or another, or a few different ways. And then some elements, sub-elements may be required and some not. So you could either have RGBW and RGB as 2 separate definitions, or you could have an RGBW where the W channel is optional. And there might be, this is where when you converge data models, you maybe have to come up with a common practice, but you have to be able to express the different ways. And so this seems to be required. But the data schemas really should be part of the protocol bindings and the mapping files. And SDF doesn't really say that you can't make a data schema part of your SDF model. In fact, there may be a lot of cases where we do want to do that. But it shouldn't be required either. It shouldn't be just assumed that there's a data schema where you have data elements. It should be that the data element in SDF should in the core file, if you will, or the abstraction should describe the data elements themselves, and then there should be a mapping file or a binding that describes what the structure looks like as it's passed between endpoints. So that's as an example.
Larry, can
Yes.
you explain that a little bit more? Maybe you have an example. I guess you do. Okay.
I do have an example. Yeah.
I do.
And so,
Awesome.
yeah, the idea is, but this is just an abstract example. It isn't even RGB or anything, but a simple property, just to show kind of what we're talking about. Okay, so the simple property is just like I say, here's a property, it's type string. Here's a compound property, and it has a data declaration that's similar to other SDF data declarations that we use in actions and events. And it says that the interaction with this property, this compound property, has separate elements that we can, compose differently, and some of them are required and some of them aren't. And there may be different types. I might be sending a number and a string together. And I want to treat this, I don't want to have to wrap this up in actions and events in order to send the compound data. I want to be able to just do pub sub or read write on it. And that's why it needs to be defined as a kind of compound data like this. So the idea is that we could reuse this inline SDF data definition to provide these named elements in the structure that each have their own semantic anchor. And I should show the JSON pointer for this as well, but of course you could have SDF property, compound one, SDF data element one. So again, if you know the ontology, you can basically graph that out and you can understand that. And then when you can annotate it in a structure in thing description and W3C thing description or something like that, you can say, here's my schema for the structure, and you can annotate the schema with these semantic elements and say this part of the schema is element one and this part of the schema carries element two. But we want to avoid that mapping here, and so we just say here are two data elements that are part of this compound property. And I think this is probably this is the abstraction that seems to cover all of the cases that I've seen so far anyway. Right, so questions now? Obviously, the other thing is unsaid is you could have multiple layers of this, and you could have obviously some folks are saying, well, maybe in SDF we should have only one layer. We should say you could have collections of simple properties, but not collections of collections. And so that's a further discussion that we need to have. But to me, I have seen cases where there are already things that we would want to represent with more than one layer, but we'd have to have specific examples, I guess, if there's some opposition to just having it be unlimited. Okay, the last one is just a pattern that comes up that is interesting to think about how to model it, and so it's basically it seems like they do it to save space and all of that, and really like to use a byte for multiple things, but it's not like a bitmap where you use a byte to have multiple separate elements. We kind of have a good pattern for that. That's just an array. But this is for more of where you reserve a few values of a scalar in order to make them overriding exclusive settings to the value. So an example is a Zigbee light. You can say when the light starts up, and that being I have a power failure and power is restored, what's the light going to do? The earlier ones just went to full brightness, which most people found extremely annoying at 3 a.m. So there's a setting now that you can either restore the last brightness, which is what most of them like to do, but also some of them are set to minimum brightness because there is a safety factor there. If I have a power failure and I want my lights to come on, if it's a legitimate emergency. So there were some compromises there, and but basically it also has a value that you could set. So, oh, when the light starts up, set it at 50%. So they encoded all this in a single parameter, which makes sense, a single property in SDF. But it's kind of weird because it has both a range, scalar range, which is limited. So what makes sense is to borrow a construct from JSON schema. This is like, to me, the most literal representation, and say this property can be any of these two things. It can be either a number between 1 and 254 that's start up at the current level, or it can be a selection from this enum where I have two constant values of 0 and 255. Now, again, you could omit the values and put them in a mapping file. In this case, I've chosen to say, well, we're going to carry the values in the schema, but you could also say, well, I might want to do it with a 16-bit number or something like that, or some other way of mapping it out. But this just shows how it would map out if you decided to put the mapping right in the schema, or right in the SDF file. That's those are the 4 cases, and I don't really have a conclusion. I just sort of the GitHub issues for these, and there's some good discussion that Karsten has started already. There are others too. There are other folks that have some other things that they'd like to see in 1.1. So this is just from my perspective, based on the things that are basically blocking issues for being able to use SDF in these other ecosystems like Zigbee and Bluetooth, where maybe not completely blocking, but what it would take to make them really want to use SDF and happy with it, and would create more ease of use for them. And really in a lot of other cases. I think they're good general cases, but they're driven by the need to get these other ecosystems in.
So Michael, can you? So this is this business where, of course, we have a different values, or different. I'm going to say gauges, maybe is my physics background term, right? To these things, for these things, like you said, the 50% value is not a value in the normal set of brightnesses. Or the last value is is outside of that completely. So
this pattern you're talking about,
yeah,
here
this pattern that there are different kinds of things. So what about the issue of so we can adapt SDF to deal with these things, but what about the issue of, okay, so you want to be able to round trip this data model into, which came from Zigbee, now you want to be able to round trip it into, I don't know, someone else, right, who doesn't have that mechanism, and you want to come back with reasonable data. Is that a goal?
Well, it is, and so the part of the discussion around that is this a fundamental pattern, or is this already too much of a mapping at this level, right? And so I had another straw man pattern that was like, well, let's just declare it as two separate things. There's a level and there's a setting, and then you have to have a way of saying they're exclusive, and that might be a better pattern overall. But I think you're hinting at where the discussion needs to go on.
Well, yeah. So I think it's about not just about what can SDF represent, because SDF is trying to represent the superset of everything else, but at the same time, it has to also be subsettable into what those other things can represent, so that we can get stuff out of it, right?
Within reason, right? I mean, there may be. This is an example of the first time you look at this, you say, "Oh, that's ugly. I would never. That's bad design." But then you think about it, and you think, "Well, actually, it kind of makes sense. The way it's encoded is efficient, But actually, as a design pattern, I wouldn't want to prohibit it, right? But there might be others that you could say, "Well, that's really something that we have to model around, if you will, or work around." We haven't encountered any of those yet, but we're not so stuck on everything absolutely has to be represented. We have to be able to, it has to be lossless. But
well, that's what I'm trying to say.
Yeah,
that's what I'm trying to say. If you go from one ecosystem into SDF into another ecosystem, and then you expect to go back again, right? The you know, the ecosystem that doesn't have way of representing something, we're going to lose that data. You can't translate into that and without losing the data, if I'm not mistaken, right?
Yeah, that's basically the idea. Exactly. Is that we want to be able to allow you to model all these different ways that people have of representing data, but do it in an abstract way that doesn't exclude any of them, which was the problem with enums.
Yeah, so in this example, the obvious next step is to add a maximum device value permitted.
Well, if you wanted to have, yeah, I mean, so the logic of devices might be extended to add that, and then you know, when you did that, you would have to change the encoding in this case because I'm specifying the encoding here. But basically, a more abstract pattern would just say type number, SDF. In fact, I think the example that's in the GitHub issue doesn't have the value constraints. It just says type number and it says SDF enum minimum device set to previous value. So in that abstraction, you could very easily extend this by adding more values to the enum. Of course, your mapping rule would have to be something like subtract all the enum values from the range and then, you know, or something like that, right? Or it might even be more ad hoc. Well, I hope that's what you were getting at. I mean,
Yes.
The extensibility, yeah. Yeah, adding the constraints definitely hurts extensibility.
So I think we will be sort of treading this path of there's always a risk of complications when translation, because these ecosystems are built differently, they have different capabilities and so on. But I think obviously the goal would be the hopeful goal is something lossless. But on the path there, we will ensure that things are useful, even if they're not perfectly lossless.
Yeah, and I think that the takeaway for me and really why I thought it was relevant to show the constraints as part of the model is that probably the more abstract, the better in terms of getting convergence. But you keep going back to, well, also though, at some point we all have to agree. Well, you know, here's where it comes down to. In the runtime, you could have two different runtimes. You could have a runtime where it's important that everyone agree on the same set of mappings and constraints so that you can do code generation on constrained devices and have them all plug and play on a network. But you can also say, well, I want to do my runtime such that it's adaptable, and I want to be able to take my mapping files and generate a mapping bridge that has two different endpoints. It has one endpoint that takes one set of constraints, and it has another endpoint that takes a different set of constraints, and it adapts one ecosystem to another, and it does that dynamically. And we're building, you know, examples of both of those as in terms of demos and what have you. But in any case, it still seems to be that the more abstract the base model is with the constraints and schemas and formats as part of mappings, that's much better. And I think that the meta thing here, and I don't have a slide on it, but I'm looking at how do you then standardize the mapping so that I can really trade mapping files around, even though this is where the extension points are. So we're not really looking at standardizing all the vocabulary, but how do we do this? You know, if I apply a set of ID numbers that for Zigbee and a different set of ID numbers for Bluetooth, but it's the same models, shouldn't the mapping files be at least sort of similar and use similar syntax and processing? So that's an area that we're, and also even when you look at what a thing does, a thing takes a set of object definitions that are very abstract, and it might add these constraints when you define a thing. So you might say, my thing uses startup current level, and it it encodes the number as a 1 to 254, and it encodes the enum as these values, right? And you can say that I have a specialized thing that specializes these objects, or you could say I have a thing that's generic, and I have a mapping file that maps my thing to my ecosystem. And so there are a bunch of choices in workflow and that I think still need to be prototyped and patterned out. But I think we're well enough informed for the basic language features now that we can do some fairly well contained examples and kind of like converge on some of these features. And I think this is a good starting set at least. And then we want to get more input on what other. I know Letter had asked for some other features as well, but I'm not sure. It was objects of objects, and whether that use case was satisfied by some of these. And so we have some other requirements that we need to look at as well.
Yeah, that's correct.
So would it be worth stepping into some of the issues that in GitHub at this point to ground where we're going?
Yeah, if there's nothing more on the agenda, we have 18 minutes, and but I could.
Well, that is actually what is next on the agenda is approaches for addressing them, and
Excuse me.
Yes, go ahead, please.
Hello, I'm Marianne Moali, and I have a more general question. That's why I prefer to ask it for now before you enter into the the GitHub topics. My question is, are you aware about the work which is under definition work in IETF project 1M2M? Because there is a data model which is quite generic, which is also doing some interworking with other protocol like ZB, and I would like to know if you had a look at this project, ETC project, and what they are doing, because they also have a data model. They are starting release 5 of the 1M2M, and they are using a new data model, which is a smart device template, which is quite generic. Looks like you are doing with 1DM. So I would like to have your view and to know if you had a look to that project.
Yes, we did. And in fact, I don't believe Alan Soloway is on, but Alan in the earlier days represented one data model. We did look at SDT, and we think that this approach is compatible with SDT. We also, though SDT didn't exactly, so SDT is more of an system interface description. So we would see as SDT as being like maybe W3C thing description and other formats that would be generated from this device, very, very device specific representation in SDF. But also we were not able to follow up much with with that organization because of the participation of Huawei in that group and the fact that we were operating as a liaison group with US companies. And so we had to keep some distance between 1M2M and our group during the period of the US Commerce Department spot regulation that they did to limit interaction with Huawei. That's since been lifted, and we can go back and we can now work with, well, two things. All of our work is in the open, so we don't really function as a liaison organization anymore, strictly undercover. So we can work with any other organization now. So when we come back, we would definitely welcome 1M2M to be back in our group discussing and harmonizing with SDT. It's unfortunate we weren't able to have them as part of the process all along, but I think we got enough interaction through Alan's participation that we're able to, more or less keep up. But yeah, I think it's there's an opportunity now going forward to work more closely with 1M2M, and we'd like to do that.
Okay, good, because they're also working on Flex container instances, and what you were describing just before is exactly the same kind of way the data are addressed in 1M, 2M, trying to make them more generic, but being at the same time being able to be specialized or specific. So yes, it would be benefit for both of the two groups to work together.
And that's basically a one data model interaction, but also definitely in the SDF language, as the users of 1M2M would want to use SDF also in their tools and workflow. And we also have similar outreach with the digital twin. There's a group in Microsoft. It isn't really an open standard, but a group in Microsoft that's, well, they do publish everything as open source, that's working on a digital twin language that has a lot of the same parallel constructions that we want to harmonize at the language level as well. So it's beyond just the models, but it's more also harmonizing at the language level. So, yeah, thanks for bringing that up.
And actually, that is one of the extra. That is actually one of the reasons to bring this work from 1DM to IETF is to get broader participation of people who might see use of this. For the very reasons we talked about at the beginning, that it was hard to find one solution that everybody could migrate to, instead of if people were able to use SDF as the kind of background or translation tool that made people happy. So this is definitely very much about ensuring that we have trying to get as big potential use of SDF as possible, reaching out to as many IoT and related organizations as possible. So that work is ongoing. But thank you, it's a good point, absolutely. Yes, any other questions? Other questions? Should we go into, can you share your browser, Michael?
Okay, so that was really my next question is, let me see, I have.
We only have like 10 minutes, but.
Oh, sure. Let's see, let me grab it. Oh, there it is. Oh, okay, it says I'm sharing my web browser, but I'm not seeing, oh, there it is. Oh, that's weird, I get another pane. Okay, cool. So, that's not it. There it is. Okay, so currently I've in the SDF repo on one data model GitHub, we have 4 open issues that roughly correspond to the 4 categories, and they're enum type, reusable property types. First, is this a good size for everyone? Everyone can see fine? No one's complaining.
Can you
okay.
make it little larger, please? It's hard to see.
Okay.
Thank you.
So, right. So
the trick is to make your window smaller, so that not to hit Control Plus, so that it transmits fewer bits and winds up bigger on our screen. It's completely.
Thank you. I never thought. You're right. Right. I get it, but I never really thought about it like that before.
Yeah.
Hang on. No, yeah. I have the weird sort of where's the toolbar kind of thing. Okay, there.
Yeah. And then just
like
make that window.
Yeah.
There. Well, okay. Well, that didn't work on your Mac because your Mac is transmitting your entire screen.
Oh, well, let's do it differently then.
Yeah, but anyway, I think we can use the plus to make it bigger.
No, let's do it this way. that should work better.
No, it doesn't on it because it's Mac and because of your choice of browser, but that's fine.
So what should I do? Go back to full screen?
No, it's fine. You're fine. Yeah.
Oh, I see. It probably just gets smaller on your screen, doesn't it? And doesn't.
That's right.
Yeah, okay. I know what it looks like. I know what I've been on the other end of that now. Now that you mention it. Okay. So here we are. Anyway, and we have 4 open issues, and everyone will have to use their own magnifiers, I guess. So I don't know what. There's some discussion on each one. Do you want to like sort of like just trip through them briefly? Start with
yeah, that would be really good.
Yeah.
That would be really good to engage.
Okay, so we've been talking about enum for a while, and I'll just sort of lay out the discussion here as I see it. And Wouter has an add because Alan's not on, but Wouter can chime in. So currently, as Karsten said, SDF or enum is currently just a JSON schema.org feature that allows you to specify an array of values, and that's all it is. They don't even have to be the same value type. So we've tried to constrain our use of JSON schema.org enum by saying they have to be, at one point we said they had to be string value pairs that had the mapping built right in. And then I think we backed off on that because, you know, we really wanted it to be abstract. But just putting just having an array of strings is something that doesn't have a lot of the qualities I was talking about earlier, like the JSON pointers to it are just array indexes, and they don't have any way of adding any more SDF qualities to each, like descriptions and other things that you might want to do, and mapping hints and things. And it's difficult to have mapping information to them. But again, enum, we might want to expand it out more and have some IETF, or sorry, IANA registration in a namespace and things like that. So here's the discussion. Basically, you know, Alan is asking for a mapping, so it's mainly around the abstraction. So, and Wouter's point is, I think what we all agree on is that we really need to represent semantic values and shouldn't have the mapping in the enum. But where we haven't really agreed yet is whether we could just use JSON schema enum as and just say that they have to be strings, and the strings have to be, you know, something special, or we add this proposed SDF enum class to the vocabulary, to the language.
Well,
that does, yeah. Okay, so there's Wouter, yeah.
I think the way out of this is to have a combination. So I just like to have the same thing as the JSON syntax, because that's clean, although it has deficits that you can't annotate anything further. So I didn't write it down, but I think I wrote a few emails about it already, is that I think I just want to keep using the enum as is, and that we can have a list of enum values like SDF enum, similar, to say what else that value can mean. So, and I think we already agreed that it would be a bad habit in combining enums of different types in a single enumeration. So you don't want to have a value 1 as an integer and a string. You don't want to do that. That's just an awful design. And I think we already agreed on not doing that more than 2 years ago.
Okay, so it sounds like where we are now, with 5 minutes left in the agenda today, is that we need to look at. So I have provided an example here of a thing that uses SDF enum. So it sounds like you're proposing a pattern that uses JSON schema.org enum with some additional annotation, and I could think of a few different ways that might work. So I think we need an example of that.
Well, frankly, the only difference that I can see is that the SDF enum value on, I think I see that correctly, on, that is being used as a standard value somewhere as a normal JSON enum. And I think that would work. And then you can even say it has the scope of the same document, but what would you do if there are two enum values called on in the same file? Are they the same or are they different? But frankly, I think if we define on, that it always will be the same. So yes, I think there would be additional things that we can do, that we can list those enum values out, maybe in IANA or whatever, but start standardizing them in a larger scope than just the scope of the model itself. And I think that's the real problem with enum values. Are they scoped to the model, or is that scoped to the domain or even larger than a domain?
So that's okay. That's really part of the discussion also. So if there's scope to the model, so we always provide a way in SDF to have a standalone data definition. So certainly they could be scoped within, say, one DM by having an SDF file that is for the domain, if you will, or for one DM even. So you could have a standalone SDF data definition with the enum. And I think for what you point out, it is an industry problem right now, these enums, because you have products that really could be harmonized in control modes and things like that, like ovens and fans and cooktops and a lot of things that really should be harmonized. And providing a place to do that for enums is good. And I was thinking, one DM could do that by using SDF data definitions and having those be at some root entry point. So you could say, here's all the enums that you can reuse in any data definition you want. But a good point has being made that maybe we should go beyond one DM and say this is an IANA thing and have some registrations there. But I think nonetheless, we need to see some specific, get down to some specific examples of what the SDF file looks like when it uses these other patterns. And I know it sounds simple, but maybe then it won't take long to develop a couple of concrete examples, just so we can have a discussion on the trade-off. So I'm not quite sure what it would look like. I can say, okay, if we had to use first, I guess.
So what I would suggest at this point is rather than going too far into the detail, because as you said, we were at the end of the thing. This is actually a really good thing to whet our appetite for the next meeting.
Exactly.
So is if we could describe the question well enough such that we can put it in, it can be literally the first agenda item next time. And is there a second item an issue that you'd like to bring up right now that may be equally enticing? Is that the right word?
Yeah, the second problem that I was hinting at, and that was already mentioned by Michael as well, at this moment we model things very, very, very flat, which is not a bad thing. But if you want to do more complex things with media, then it would be good to have more compound statements, like that you have data within JSON data, basically JSON support of JSON, nested JSON objects, to describe how that is on the wire. That's everybody's own choice. But I think having that kind of grouping functionality would be a nice addition.
And I think this is another great example of where I'm proposing some kind of abstract way of doing that doesn't actually use the JSON-schema.org. And I think Wouter is looking for some solution that's closer to just looking at like a JSON object. But, you know, again, I think we need to look at some concrete examples because sometimes it makes sense to have, you know, and I think Karsten brings up, how does the naming work? And so maybe as another, for another second issue, we can have some comments on this issue that get closer to the question of whether to just reuse the JSON-schema.org thing directly or whether we need to have a more elaborate SDF way of doing it. I think if I captured Walter's question, maybe.
Well, I can give a few examples of what OCF is doing with media. So
I think that's what we want to look at. Yeah, is that you're
and then immediately you can see that it's complex and flattening it out. Well, you can flatten it out. I'm not saying that it is impossible, but it's just ugly modeling wise. So if that would be the total consensus in that everything needs to be flattened out, well, so be it, but that would not be my first preference.
I'm not sure it's sufficient either, because in the examples I've looked at, it's important to say that you, even at the abstract level, it's important to say that you're providing an interaction that gives you this data as part of the interaction that's more than one data element. And even having to do that, I think, is where you start introducing the grouping issue, and whether you want to add structure or keep it structure neutral. Those are some of the fine points. But I think once you've gone down that path, it's like, you know, there needs to be all these questions come up of, do I have to name them all, or can I just point to a bunch of them? And I think we need to, that's where we need to go next then. So I guess, Michael, is this what you were looking for, a second issue to put on the agenda?
Yeah, something to that would, yeah, and that was a really good explanation about the flatness versus not and stuff like that.
Yeah,
I'm just surprised when I scroll my mouse that your screen doesn't scroll now. Yeah, so
we need a tool that works that way, but that's a different discussion for a different time.
Exactly. It just startled me for a moment that didn't work. So that's what I would propose as a structure, is that we get into some issues. We want to probably give a high level notion of what the conflict is, or you know, if they get resolved in the GitHub, that's great. If they don't, then, you know, that's a topic of discussion. Now, I think we decided that our next meeting would be the one at the IETF in November, or is that too far away?
I think we aim to try to have a virtual interim before, but we need to be scheduled as a working group before we can schedule a virtual interim. So I'm not quite sure we can make it time-wise. It's a bit tight.
Yeah, I think so. It's going to be the second week of November. Oh,
so I'm probably we are at the very end of October. If you want to, there's 2 week time before you can, if you want to schedule a meeting.
So we could target something for the week of October 26th, which is in 2 weeks. Yeah. And I think we should be able to, later this week, we should be able to officially do that. So is that a good time? This slot is good for people, or at least the people who came, obviously it was good for them.
Yeah, I don't know if we should try to find a slot with, should we try to find a slot that is more friendly to the US, or
Michael,
I don't mind, but I don't mind at all.
To Michael.
He has to get up and walk. He has to get up and walk his dog anyway.
Me because don't ask me. I'm always up at this time. But I think it'd be okay. I know, you know, we can probably get like Alan Soloway. I don't know. I'm just thinking of individuals. No one I know. A lot of these folks are in the next time zone over, and it's like much. Even the difference between 6 and 7 is a big deal for us in the U.S. I guess.
Yep.
I think it's okay for now.
Okay.
And then if you know, if we think that it's a problem, we can shift it later. And it also lines up with the 1DM slot with a lot of the people already doing this, but we're thinking for the model convergence stuff, we're going to need a new slot that's more friendly to other folks anyway. So this turns out to be a slot that people already have on their calendars.
Okay, so Nicholas and I are going to organize another meeting probably for 2 weeks from today. And then we have a meeting scheduled for IETF 109. And the process of running things through with the on GitHub, we may want to transition this repo from one data model to ASDF, but I think that's something we can discuss offline.
Yeah, we were planning on moving when we get the WG formed, we were going to move the repo, to an IETF repo.
Or if that's the only thing there, we could just rename the org as I don't know what makes more sense, but anyway. Okay, so is there anything else today that anyone wants to bring up as part of the meeting content before we go our own ways? Thank you for the slides, Karsten and Michael. I think it really bit into the content really well. And with that, I'm going to stop the recording.
Thank you.